Question 27. Let f of x equal x times e to the power of negative 2x. It is given that the first derivative f dash of x is equal to e to the power of negative 2x minus 2x times e to the power of negative 2x. Part A. Show that the second derivative f double dash of x is equal to 4 times x minus 1 in brackets times e to the power of negative 2x. The first step is to factorize out e to the power of negative 2x from both terms of the first derivative. So the first derivative f dash of x can be written as e to the power of negative 2x times 1 minus 2x in brackets. We have a product of two functions in x, so apply the product rule to find the second derivative f double dash of x. So letting u equal e to the power of negative 2x and v equal 1 minus 2x, and applying the product rule, which is u dash v plus uv dash, we get f double dash of x is equal to negative 2 times e to the power of negative 2x times 1 minus 2x in brackets plus e to the power of negative 2x times negative 2. And expanding the brackets here, f double dash of x is equal to negative 2 times e to the power of negative 2x plus 4x times e to the power of negative 2x minus 2 times e to the power of negative 2x. Now combining like terms, we get f double dash of x is equal to 4x times e to the power of negative 2x minus 4 times e to the power of negative 2x. And factorizing out 4e to the power of negative 2x from both of these terms, we get f double dash of x is equal to 4 times e to the power of negative 2x times x minus 1 in brackets, which equals 4 times x minus 1 in brackets times e to the power of negative 2x as required. Part B. Find any stationary points of f of x and determine their nature. To find any stationary points, solve for x the equation, the first derivative f dash of x equals 0. Now the first derivative is e to the power of negative 2x times 1 minus 2x in brackets, and we're going to make this equal to 0. Note that e to the power of negative 2x, being a positive exponential function, will be greater than 0 for all values of x. So the only way the left-hand side can equal 0 is if 1 minus 2x equals 0, which means x equals half. So a stationary point exists at half times e to the power of negative 1. We get this value by substituting half into the original function, x times e to the power of negative 2x. Next, we test the stationary point by checking the value of the second derivative f double dash of x when x equals half. So substituting x equals half into the second derivative, we get f double dash of half is equal to 4 times half minus 1 times e to the power of negative 2 times half, which equals negative 0.735 and so on, which is less than 0. Hence, the stationary point at half e to the power of negative 1 is a local maximum. Part C. Sketch the curve y equals x times e to the power of negative 2x, showing any stationary points, points of inflection, and intercepts with the axes. Substituting x equals 0 into the original function, we get f of 0 equals 0, hence the curve passes through the origin. Next, find points of inflection by solving the equation f double dash of x equals 0, where f double dash of x represents the second derivative. So the equation is 4 times x minus 1 in brackets times e to the power of negative 2x equals 0, and the only way the left-hand side can equal 0 is if x minus 1 equals 0. So we have a potential point of inflection where x equals 1, and the corresponding y value is found by substituting 1 into the original function. So f of 1 is equal to e to the power of negative 2. So we have a potential point of inflection at 1, e to the power of negative 2. We need to test this point of inflection by looking for a sign change in the second derivative around x equals 1. So I'm going to test f double dash of 0.9, and I'll get negative 0.066 and so on, which is negative, and f double dash of 1.1 is equal to 0.0443, which is positive. So we have a sign change of f double dash of x around x equals 1. Hence the point 1 comma e to the power of negative 2 is a point of inflection. Also, as x approaches infinity, y approaches 0 from above, so the x-axis is a horizontal asymptote. The final step is to sketch the curve, and it'll look something like this. So here's the local maximum at half comma half times e to the power of negative 1. Here is the point of inflection at 1 comma e to the power of negative 2, and the curve passes through the origin here.